Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Nursyahirah Binti. My metric number 1937113. My supervisor as Prof. Dr. Latifah Binti Abdul Manaf. Today I will be presenting to you my final year project that is titled Evaluation of Paper Waste Performance as an Alternative Aggregate in Brick Production. So for the introduction, MSW recognized as waste or garbage that dump from residential and industrial areas. With fast population growth, the output MSW was increased from 2012 to 2020. Malaysia's method of waste disposal is unsanitary landfill. Most MSW is buried in landfill, burned in incinerators, or end up in open dump. As urbanization expanded, several landfills reached full capacity, making it impossible to build a new landfill site due to lack of land or for disposal. There are four problem statements in this study. First, wasting the natural resources. Expert indicate 24 trees are needed to manufacture 1 ton of printing paper. 42% of wood production used to manufacture paper. Second, pollution. When paper disposed, methane is released, potent to greenhouse gas. The chemicals used in paper manufacturing lead to water contamination. Third, total generation rate. The total generation rate of paper is 86.305 ton per year. The largest producer are high-income countries with high percentage of paper. Lastly, high-cost production. The cost for a unit of cement brick is 20 cents. This does not include the cost for delivery charge, storage charge, and labors. For the significance of study, first, economic saving. The raw material is cheap and easily available. It also decreasing the amount of labor and energy expenses. Second, encourage people in recycling. Means that it preserves landfill space and prevent contaminant out. Also, it promotes paper waste recycling in areas that do not have the recycling services. Third, environmentally friendly. It decreases the use of cement in the mixture. The carbon footprint can also be minimized during processing. There are two research objectives in this study. First, to identify the ideal paper waste ratio performance based on the density, compression strength, and water absorption. Second, to evaluate the relationship between those three parameters. The research question in the study is, first, what is the best ratio of paper waste that required to produce a brick as an alternative aggregate? Second, how is the relationship of fabricated brick based on those two parameters? The literature review is, first, MSW dominate the total solid waste composition in Malaysia. Second, paper waste has been increased. Hence, research being carried out to establish technologies that generate fewer waste. Third, use of recycled materials in construction industry is important for sustainable development, like reuse paper waste to create papercrete brick. Fourth, papercrete can replace the usual concrete that can reduce weight, cost, and carbon emission. Next, papercrete is much lighter, strong ability to absorb water, and higher compressive strength if decrease the paper. Finally, papercrete brick can be used for non-load bearing walls. For methodology, first, sample preparation. For preparation of paper pulp, paper was cut into small pieces, then soaked in water for 24 hours until degraded into paste-like shape. After squeezing out extra water, put them into the blender to make the paper pulp. For casting of specimen, 4 mixed proportion including control used in the study. This is the example of ratio that I used for making the papercrete brick. The mold had been borrowed from the Faculty of Engineering, and the size of mold is 50 x 50 x 50 in millimeter. Mixing of ingredients. The mixing was done manually. The water cement ratio used is 0.5. The set of papercrete brick be measured in 7, 14, and 21st day. This is used to increase the strength of the brick. For sample analysis, the density, the brick weight in electronic weighing system at the Faculty of Engineering. The densities were determined by dividing their mass by its effective volume. For compressive strength, after the brick completely dry, the load is applied at constant rate and the maximum load at failure is recorded. This is the formula that I use to calculate the compressive strength of brick. for water absorption, dry the specimen under the sun until get the constant mass, then put in the room temperature and obtain its first weight. Next, immerse them in water for 24 hours at 28 plus 2 degrees Celsius. Finally, clear traces of water and weight the specimen for the second weight. This is the formula that I use to calculate the percentage of water absorption. For data analysis, the research is to investigate the relation between variables. In this study, I use Spearman's rank order correlation and Pearson correlation analysis. A preliminary analysis used to test the violation and suitability of the data. This study is run by using IBM SPSS software. This is the result for my objective 1. The table showed the density of peppercrete brick. As we can see, P20 specimen has the highest density before and after water curing compared to other specimen, as P20 specimen contain less paper waste. The ratio of paper waste and method of water curing impact the density of specimen. Ratio of liquid cement content and curing influence the density of brick. Density of peppercrete increase when ratio of paper waste decrease. The figures show percentage of water absorption. The specimen that undergo water curing at 21st day has highest value compared to 7 and 14 day. The specimen with 30% and 40% of waste paper has higher of water absorption compared to 20% of waste paper. The water absorption increases with the immersion time because the capillary action conduct the water molecules in the material and fill in the voids. Thus, when the amount of paper waste is higher, the water absorption will increase. Third, this is the figure showed the compressive strength. As we can see, the highest compressive strength is specimen that contains 20% of waste paper under water curing process. In water curing process, compressive strength of concrete increases with age. The concrete will not develop optimal compressive strength if moisture is not retained, and cracking may occur. The lowest percentage of waste paper in specimen, the highest the compressive strength. This is the result and discussion for my objective 2. First, relationship between density and water absorption. The table showed the correlation coefficient between the density and water absorption. There was statistically significant very strong with negative correlation between density and water absorption. Since P less than 0.05, the null hypothesis is rejected. Thus, there is statistically significant relationship between density and water absorption. This is a scatter plot graph for density brick against water absorption. A linear relationship using Spearman rank order correlation between density and water absorption is given as the equation below. The analysis of regression coefficient R square showed that this model explains 85.9% of variability in density. The linear equation showed that high brick density is related to less water absorption. Second, this is a relationship between density and compressive strength. Table show the correlation coefficient for density of brick and compression strength percentage. There was statistically significant strong positive correlation between density and compression strength. Since P less than 0.05, null hypothesis is rejected. Thus, there is statistically significant relationship between the density and compression strength. The figure showed the scatter plot graph for density against compression strength. The equation for a linear relationship using Spearman order correlation is shown above. The R square showed that this model explains 51.6% of variability in compressive strength. The positive value indicates the strength increases with the density. The third one is the relationship between compressive strength and water absorption. The table showed the correlation coefficient between compressive strength and water absorption. For this analysis, I use the Pearson correlation because the p-value is more than 0.05. There was statistically significant strong negative correlation between water absorption and compressive strength. There is statistically significant relationship between water absorption and compression strength. The figure showed the scatter plot graph for water absorption against compression strength. This linear equation expresses the relationship as y equal to negative 5.07x plus 46.42. This linear equation indicates that one water absorption may increase the sample strength by approximately 46.42 if the unit of water absorption is 5.07. The R squared showed that this model explains 57.6% of variability in compression strength. The correlation can be found that higher compression strength and lower water absorption is correlated. So, the conclusion for objective 1, P20 is the ideal ratio in breed production because it has the higher compressive strength, highest density as P20 contain less of vapor waste and has lowest of water absorption because porosity is decreased. So, these parameters have proven that the specimen for P20 is suitable for ratio in breed production. So, the conclusion for objective 2, for the three parameters that I used, it showed that all of the three have the relationship between among them. So, for the recommendation, use manufacturing technology for paper crepe brick to manufacture other eco-friendly alternative building material from similar solid waste like sawdust. More effect toward the physical and chemical properties of paper crepe by extend more longer the water curing period. For the application, the paper crepe brick have gained potential for use in lightweight load-bearing application which are not exposed to the weather element. Paper crepe brick may be used as insulation for two interior walls. So this is the list of reference I used in this study. So that's all from me. Thank you.